All right, our last two sections of material today and tomorrow are going to extend what we have done so far with systems of equations to include three variables. So in terms of a graphical image, you can think about an XY plane being a two-dimensional graph. We usually graph inside of 2 dimensions. What actually happens when we have 3 dimensions is this. We end up with 3 variables, an X, Y, and a Z coordinate. So these represent points in space. We're not going to graph them. My Calc 3 students actually get to graph these, and it's really tough to graph in 3 dimensions. So what we are going to do, however, is look for intersection points. Now, if you can imagine, in the plane we only had 3 possibilities. 2 lines either intersect, they're parallel, or they're the same line. We actually have more possibilities of that than that in 3 dimensions. They could intersect, they could be parallel, or they could be skew. Skew means lines that don't intersect and they aren't parallel. And if you think about like the classroom here, and you look at this line that would be the ceiling meeting the wall over here by the door, and you look behind me at where the floor meets the wall behind me, those 2 lines are never going to intersect, but they're also not parallel. And so that would be an example of skew lines. So the ones that we're going to work with, I'm going to tell you, are in fact going to have intersections. So every homework problem I've looked at so far, I haven't seen anything that they've done where they're giving you something where, oh, look, it is skew, oh my goodness, or oh, look, there were parallel lines going on there and I didn't realize it. So if you're getting weird things happening, kind of like were happening at the end of that last assignment where we do in fact have lines that were parallel or the same line, that's not going to happen in the 3-dimensional questions that we're working in, okay? So we are going to get an X, a Y, and a Z coordinate. The first one that we're going to do has sort of partially already solved. So just kind of introducing us to the idea of what's happening here. If you see on this one, you see the first equation has 1 variable, the second equation has 2 variables, and the third equation has 3 variables. Just to give you, just pause for a second, I'll put it back on this slide, but this is where we're headed, where there are 3 variables in 3 equations. But our goal, as we're working through it, is eventually to get things like this to happen with those 3 equations where it doesn't start out this way. We want to eliminate variables, places where the variables won't have 3 of them in a single equation. So on this one, it's actually really nice, because if you take a look and you look at that first equation, you should be able to tell me what Z equals. What is it? It's 2. Now, as we work through these, every time I'm going to number my equations so that we make sure that I don't lose you or confuse you with which equation I'm talking about. So equation number 1, if I take equation number 1, it only has 1 variable, so I can solve for it. And if I divide by -2, I find out that, in fact, Z is equal to 2. That's really good information. Because the second equation, it only has 2 variables, and one of them is Z. And I know now what Z is. Z is 2. So I can take equation number 2, which is 2y minus Z equals 8. And I can plug in, right here, the 2 for the Z. So I can replace 2y minus 2 equals 8. And now I'm again down to 1 variable. Can add my 2 to both sides. So 2y equals 10, or y equals what? 5. Very good. Now I have Z solved for, I have y solved for, and in my third equation, in fact, I have 3 variables, but I already know what 2 of them are. So if I take equation number 3, which is -2x plus y plus 3z equals 9. X I don't know, so this stays -2x. But y is 5, so this is plus 5. Plus 3 times, and z is 2, so it's 3 times 2 equals 9. Again, I'm down to 1 variable. So I have 5 plus 6 equals 9. 5 and 6 are 11. So what is 9 minus 11? Yep, -2. What would x be? 1. Okay, so on this one, the way we would write our answer is an ordered triple. We always wrote ordered pairs before. We either wrote ordered pairs or we give context. We're going to do the same thing. We're going to write ordered triple. So x is 1, y is 5, and z is 2. And that would be my solution.
So you write the order triple in alphabetical order?
You do. It's alphabetical order. Yeah, x, y, z. I'll jot that in there just for reference. Yeah. Okay, I'm going to let you write down the next equation just so that we can start with it next time. But we won't start the equation, it's our system itself. But this is our system, and our goal as we do this is to do sort of like a glorified elimination method. I want to eliminate things. I want to get rid of them because if I can have fewer variables, I stand a better chance at solving, just like on that last problem. When I had an equation that had fewer variables, it was easier to work with. So you'll notice on the homework that I've handed out, the first 2 problems, 1 and 2, are like the problem I already did. So you should be able to go ahead and complete those. Everything after that is ones we haven't done yet. It might sort of start to look like the last 3 resemble them, but they're sort of a mix of what we've done and what we haven't done, so I'd ask you to just pause on that for now. You'll notice it's not very long, it's only 6 questions. Your next homework assignment for me is equally as short, but you have all of the legwork to do the setup because it's application problems, just like the last section we did, okay? So go ahead and do problems 1 and 2. This obviously won't be assigned to be due next time, though. It will be due Friday, as will your last assignment that we will cover next time.